that we have in our project, right? You're looking at a typical lighting panel that we have in our project. Oops. Go down here. Full screen. Okay. So I have my 225 amp panel. This is my 225 amp, right? This is your 225 amp panel coming and feeding 20 amp circuits three phase. Right? Everybody understand these are phase A, B, C, A, B, C, A, B, C from both sides. Can I have thumbs up, Chad? We fully understand. Then right next to it, you're going to have something called the lighting control panel. This is lighting control panel. So this is lighting panel. This is lighting panel. And right next to it, Andrew, my friend, is something called lighting control panel. Everybody's okay with that? They will typically, you enable them with say 2 inches or 3 inch. This is a 3-inch conduit between them. 3-inch EMT conduit tying the two together. That's one way of doing it. 3-inch conduit tying the two together. Cool? Thumbs up? This panel could be as big size-wise as the lighting panel. Any question? Does everybody understand that we have 2 different panels? You guys know this fully. Understand it. We size it. This one, we're going to size it based on how many relays we need to control the lighting system. So I fully understand that you guys understand this. Here's the phases. Here's a neutral, right? I'm showing just the ground. I'm not showing the ground. The first thing they do when you have a lighting control panel is you need to power the lighting control panel. The first thing you need to do. So what did they take? A 20 amp circuit, hot and a neutral, take it to a transformer. Can you guys see the transformer? And this transformer take the voltage from 120 volt to one side and convert it to 24 volt. Can I have thumbs up, Chad? These 24 volt have 2 functions. Function number 1 is to power the electronics inside the lighting control panel, right? They need power, juice. Function number 2 to get you the 24 volt to the switch. So when you turn things on and off, you get 24 volts because you don't use 120. That's what lighting control panel is. Lighting control panel is to replace the 120 switches by 24 volt switches, safer, easy to install, cheaper to install, number 1. Number 2, to also interface them with occupancy sensors, guys. Interface them with occupancy sensors so you can move into this room. Since that you're in this room, will send a signal to the relay to turn the relay on and off. Cool? Okay, so up to this point, any question about this side? Piece of cake, right? Now let's go to this side. Now with each one of these guys, there's a relay. Each one is inside. This is a relay. Relay 1, relay 2, relay 3. With relays, you guys learned that relay has a coil and set of contacts. Every relay has a coil and a set of contacts, right? You guys understand how relays work. Relays, you put voltage across the coils, bam, they close shut, right? This is a relay 1. I'm going to call this is just right in here. I want to complicate it. I'm going to call this is R1. This will be R2. This will be R3, right? Relay 1, relay 2, relay 3. These are called single pole relays. Why single pole? They are one pole, one contact. Can I have thumbs up, Chad? Single pole relays? Cool. Let's go wire a set of lights from these relays. That's what you guys are going to be doing. Let's go take a set of lights and wire them from these relays. Cool? So any question about this? Now, how many relays you can put in a panel? You can put in a panel, typically I think there are 4 relays, all the way up to 48 relays and even more. They can put as many relays as you want. Typically 48 relays, he'll talk about the technical stuff. 48 relays is common, 24 relays is common. So 24 of these, 1, 2, 3. Either single pole, like you're saying, or 2 pole. If they're 2 pole, they contact separately 2 contacts. Let's talk about a single pole, the easiest one. Okay, any question about this so far? Piece of cake, right? All right, let's go take a couple of lights. So I have a fluorescent light. Here's a fluorescent light. And let's just say I have 2 fluorescent lights. These are my lights. And I need to control these 2 fluorescent lights. This is L1, L light, and a light. These are 2 lights. And I need to control them from a low voltage switch. Here's a low voltage switch. Let's put a low voltage switch here. This is LV. Cool. Cool. I have an LV switch, standalone, and I have two lights, and I need to control them from here. Shall we do that? Right? Shall we do that? Okay, the first thing you need to do is to bring, so remember, let's just say, to make it more serious, how many lights we said we're going to put in a circuit? We're going to put in a circuit, say 18, we said maximum 18. So let's just say this will represent 18, that will be what? 9 lights here and 9 lights here. So imagine, these are all 9 lights. 9 to 18 lights all together. Take this, let's start wiring. When you start wiring, the first thing you need to do, guys, is to grab a circuit. Okay, so here's circuit 1, circuit 2, circuit 3, circuit 4, circuit 5, circuit 5, circuit 6, right? Circuit 7, circuit 8. And which circuit do you guys want to do? Shall we go grab circuit 4? Circuit number 4? Shall we? Okay, grab circuit number 4. Right in here, the hot. Bring the hot in here, land the hot into one side of the contact. Can you guys see what I did? I landed the hot on one side of the contact. Can I have thumbs up, Chad? So circuit number 2 now is feeding the one side of the contact. From the other side of the contact, I'm going to make a different color, and it's going to get complicated. It's a little bit, I'm going to take it back. Can you guys see where I'm taking it back? Taking it back. See what I did? I took the hot to the contacts of the relay. Cool. Now from here, I'm going to come out of here and go to my lighting fixture. So I brought the hot to my lighting fixture. Can I have a thumbs up, Chad? The only thing we did is we just brought the hot to a contactor so we can open and close, right? Can you see that? Now, in order for this, and of course from here, you're going to jump to go to the second one, right? So these two sets of fixtures have the hot now coming to them. What do you need for the fixture to work too? Neutral, thank you, sir. So what do you do with the neutral? Grab the neutral here, see the neutral, and bring the neutral, and from here and here. Now these two fixtures, gentlemen, have hot and a neutral coming to them, and this will be your circuit. This will be let's say 2 conductors number 12. 2 conductors number 12 in a conduit, in an EMT conduit, coming all the way to feeding the fixture. Can I have thumbs up, Chad? We got it. Okay, this is easy. That's so these will, when you guys label these in Revit, these will be labeled circuit number 2, right? Circuit number 4 feeding them. Cool. Now let's go to the control side. The control side, let me use, gosh, which color I'm going to use? I'm running out of colors here. Let me use the black. Well, okay. Well, let's use the blue again as my contact. So now this is the high voltage section. Let's go to the relay. Now here's how they do the relays. They grab the transformer from here and tie it to one side of the coil. Now I brought the 24 volt to the coil, and out of the 24 volt coil, can you guys see it come here and bring this one to one side of the switch? One side of the switch. Can you guys see that? From the other side of the switch, I'm going to go all the way back and come back and tie it to here. Okay, so this is my switch. This wiring here is typically 2 conductors number 16. 2 conductors number 16. Okay, let's see what this works. When you turn this, can you guys see the 24 volt is coming right here? When you close this low voltage switch, 24 volt, what happened? You bring the 24 volt and put them across what? The coil. When you put the 24 volt across the coil, what happened to this contactor? Shot. When this shot, what happened to these lights? Go on. This is the concept of low voltage lighting control system. Any questions, any comments? Any questions, any comments? See how easy that is? You brought the 24 volt across the coil via at a low voltage. This will be called in Revit. When you guys place them today or tomorrow, when you start placing them, every time it says a low voltage switch, you're going to go grab a low voltage switch, 24 volt. If it doesn't say a low voltage switch, they're talking about 120 switches, the ones on the wall. They look alike, but the voltage is different. Okay? So that's basically the one concept. Again, what they do, guys, so this is relay 1. So when you guys do the circuit there, so this, then you're going to have a relay schedule. I'm going to ask you to have a relay schedule. I'm going to ask you to have a relay schedule. And in your relay schedule, it's going to look something like this. I need the relay number, circuit number, location. Okay, so circuit number 4, relay number, what number is a relay? Relay number 1, location, what do you guys want this location to be? Room 15, so room 15. This is called relay schedule. Can you guys see that? Relay schedule. You have the circuit, and you have the relay that landing, the circuit is landing on that relay. Relay 1, right? Relay 1, and which area is controlled by this relay? Which area is controlled by this relay? Can I have thumbs up, Chad? We fully understand that one? So when you have a low voltage control system, you have 2 circuits. You have the power circuit coming to the lights. You have the low voltage circuit coming to the switch, the controller. The controller. Now, obviously, this is not why we actually have a low voltage system. Now let's go interface the low voltage system with an occupancy sensor. Now just imagine for a second, take this low voltage switch out of the picture and put an occupancy sensor here. So every time you move in, it senses you, close the relay, turn the light on. It has a timer on it. It times for 15 minutes, no movement. It de-energizes the circuit, de-energizes the coil, and it turns the light on. Same concept. You can imagine this could be an occupancy sensor too. Can I have thumbs up, Chad? We fully understand that one. So you can imagine if this was low voltage switch or occupancy sensor, almost identical. There's power pack, some of them called power pack, but occupancy sensor interface, almost similar. You have a sensor here that senses a movement, close the contact, and instead of you flipping the contact closed, sensor will close the contacts. When you close the contact, you bring 24 volt across the coil will energize, bam, shut that contact, and that light is up and running. That light is up and running. Okay? Now, if I want to control, can you guys see that? Can I control these 2 sets of light individually the way I'm wiring right now? Is there any way I can control them individually? No. The only way you can control them individually is by rewiring them to different relays. So tomorrow and today, when you start laying out your lights in Revit, you have multiple rooms. Every room is going to have its own switch, right? Every time you hear a word as switch, in the back of your mind, you have to be talking about what? Relay. So let's take another circuit and switch it from an occupancy sensor, if you guys don't mind me. Let's take another 2 sets of lights. Here's another 2 sets of lights. I have another 8 lights here and another 8 lights here. Cool. And I need to power, these are in a different room. These are in 2 different rooms, and I want to power them from an occupancy sensor, right? Occ sensor. And I have an occupancy sensor. So occupancy sensor is, as far as you're concerned, there's a contact here, there's a few things inside it, but all what you care is a contact here. I want this occ sensor, occupancy sensor, to control these 2 lights, right? You guys have an issue with that? Occ sensor, control these 2 lights. My question for you, now I have 8 fixtures, 8, 16 fixture, and I have here 18 fixture. Can I add these 18 to the same circuit? I have 18 here and another 16. Can I add it to the same circuit? No. We remember the criteria for circuiting? We said 18 circuits or more. So I am forced to bring a separate circuit to these sets of fixtures. Do you understand what I'm saying here? You're forced to put another circuit. Though you could have fed them from the same circuit, control them differently. They could have the same circuit but controlled differently. But in this case, I have to pull a new circuit. So let's go pull a new circuit. So let's grab circuit, which circuit do you guys want? It's going to get ugly here. Let's go grab circuit number 6 because it's closer. I'm moving with circuit number 6. I'm going to land circuit number 6 on one side of the relay. On the other side of the relay, I'm going to come out with here, right? Can you guys with me? And feed my fixture. And I need my neutral, so I grab my neutral from here and to here, and then jumped here. And I want to get my hot into the other light. Okay, so now we brought the power from, can you see how we brought the power to the lights directly, right? Thumbs up, Chad. Yes? No? Cool? Adam, my friend? Cool? Yeah? So we brought the light to these set of fixtures. Now, we're going to bring the low voltage. The low voltage, I'm going to use relay number 2. Can I use relay number 1? If you use relay number 1, then every time, these are 2 different rooms. Every time this room, the light goes on in this room, it also goes on in the other room. Does that make sense to you? So I have to use different relays. Okay, so let's go use a different relay. Here's what we typically do, guys, for different relays. And again, I'm simplifying the situation. I need to bring voltage, so they bring the voltage from here to this side. And then from that side, you come down to one side of the occupancy sensor. Out of the other side of the occupancy sensor, how did I do that one? So I brought one side to it. Okay.
You want to bring power from me.
I brought, where did I bring? I think I missed something here. I brought the power from one end. Okay. I brought the end here, so I have, yeah, this should have gone from here all the way up to this side. And then you can see how it gets interesting after a while. Here's my relay. And then I grab my side and put it right here. Can you see that? I know it gets interesting. You're bringing 24 volts. So every time you turn this occupancy sensor, and there's some juice in it and controlling this contact here, I'm simplifying it. This occupancy sensor will control this relay. This relay will shut down this, and the light here will go on. Can you guys see that? Let's put this in the schedule. When I ask you to write a schedule, a relay schedule, now let's write a relay schedule. Circuit number 6, relay number 2, room number, give me a number, 16. Any question? So what we really did is we interfaced a lighting control panel with a lighting panel with the low voltage devices. These are pilot devices, low voltage devices, to control a bunch of lights. Any question? Any question? Now my question for you guys, can I use circuit? Now both circuits are loaded here. What if I have can I use one circuit to feed 2 different locations and control them differently? Yes. So take this example. I don't want to draw it because it gets complicated. It gets messy here. Not complicated really, but messy. So let's just say we have another circuit, circuit number A. Let's go circuit number 1. I have circuit number 1. Cool. Circuit number 1 is actually controlling relay number 3 and room number 17, and also circuit number 1 controlling relay number 4 and room number 18. Does that work? Right? I have one circuit feeding 2 relays to control. Why do I have 2 relays? Why not relay? Because I have 2 rooms. Every time you have a room, or you have a different level of switching, you have to have a relay. For example, if you guys look at this room here, I have 1, 2, I have all these levels of light. 1, 2, 3, 4, 5. How many relays do I need to make the system work? To work exactly like I want it, to turn them on and off individually. I have 5 switches. How many relays do I need? 5 relays. If you got this concept, you're done. 5 switches, every switch have to control a relay. Otherwise, if you have one switch controlling all the relays, a relay means a light. So if I want to switch different levels in this room, every time I have a one low voltage switch, they have to interface with what? With a relay. A switch, a relay. Can I get you guys to understand? Every switch has to go with a relay. Okay? Otherwise you can't. You either turn them all on or all off if you have one relay. Right? Obviously you don't want to do that. So every switch has to have a relay. But
You're limited to the number of lights on each relay, aren't you?
yes. The number of lights is typically the 18 fixtures on one circuit. How much amps you can put in a relay? Relays, guys, most of relays are rated for 20 amps. So don't worry about them. As long so this relay is rated for typically 20 amps, 20 amps, 20 amps, right? So it matches the circuit breaker. As long as you don't exceed the circuit breaker, you're good with the relay. If the circuit breaker is good, you're good with the relay. Any question, any comment, guys, about the low voltage lighting control system? Our speaker today, when he shows you, I don't know if he goes that deal. If from my past experience, they don't go into the detail of the wiring, so you get confused. How the heck is this put together? Cool. So the last thing to summarize, when you start circuiting, guys, you're going to pick up the lighting control panel and circuit the lighting control panel and rev it. You're going to grab the panel, give it a circuit. So what does circuit 2 do, by the way? What does circuit 2 do? Thank you. What does circuit 2 do? Powers the lighting control panel. Bring power to the lighting control panel. What does circuit 4, 6, and 8 do? They power the lights, right? And then we can control them with the relays. How many relays I can stack in here? 48. I think they go in increments of 6. If you use increments of 6, for the most part. There's different manufacturers, but if you like 6, 12, 18, 24, if you move with that 6 increment, you're very close to the truth. Different manufacturers have them differently. That's a question for Keith. So 24 and 48 relay panels are not unheard of. Now, obviously, Kerry, this is not why we use the lighting control panel. Otherwise, might as well use switches, right? So we interface it with occupancy sensor. The second thing that we do, guys, is we put timers here. This is the brain controller. They have a PLC, almost as powerful as a PLC controller here, if not more. They have a non-programmable and non-programmable controller right in here. And these, I want to bring to your attention, guys. This will be powered. Remember that power that we brought here? I don't want to complicate it, but this will have its own 24 volt. 24 volt here, right, coming from this transformer. Can you guys see that? I don't want to put the wire. I have a controller here. Now, what the heck is a controller? I can make a contacts. This controller has contacts. Can you guys see these contacts? Without any external wiring, I can make this controller has timers, counters, everything you need. I can make the controller interface with these contacts exactly like a PLC. Exactly like a PLC. And make it turn on and off the light without any exterior devices. Can I have thumbs up, chat, for this? Completely. That's the power of the low voltage control. The power of low voltage control is not these external devices. That's worthless. The power is right the controller, the brain, the PLC that you can see on the wall. You can power this one, and it actually controls contacts like a PLC and can turn the light on and off, so you can program it to turn sweep the light at 10 o'clock when the janitors come and clean the offices, turn all the light off except hallways for security, right? All this could be programmed where? Right into that boy.
That's where you hook up to your computer too, right?
Thank you. Then the possibility is endless. Now this could have wired or wireless interface with the internet, where you can sit at home and actually monitor what's going on with your lighting control panel. So you can have, and my friend here will come and talk about it. So this will have, I don't know, internet, with the communication interface. This will have a communication interface, wired, wireless, right? So you can communicate with it wired or wireless.
Once we set up that you could set them up so that in the home office you knew what was going on in the.
You got it. You're absolutely right. This communication is two-way street, depending on what controller you have. You can pull the information about your lighting system and see how the lights are going, or you can initiate an order to turn things on and off, depending on what controller you have. So that's the power of low voltage lighting control system. Cool? From your phone, absolutely. Now, another interface important, guys, for lighting control panel. Security, fire alarm. So imagine you have a fire in your building, and there's certain exit lights, the dark light. What they do is they send a signal from here to the fire. If there's a fire condition, it receives a signal to turn certain lights on that closer to the emergency exits, right? Security. You can interface it with the security panel. Somebody's roaming the hallways outside, a sensor, a security sensor picked it up. It will send a signal to the lighting control panel, turn the light on, right? Among other things. Call the police, start the machine gun. You know, the possibility is endless. Can you guys see the interface? So here's with this come an interface between the lighting system and the security system, the fire alarm system, building automation system. That's the only reason why they have this building automation system. They can interface it with the HVAC system, for example. Nobody's moving in this room, right? So the sensor turns the light off. Nobody's moving. It sends the signal to the HVAC controller. The HVAC controller, you know what? There's a damper in this room, and we're heating this room for nothing, right? Why don't we just shut that damper? So it saves energy. So they go shut certain dampers off, lower or control the speed of the VFD on the air handling unit. Can you guys see how powerful that lighting control panel is? Can I have thumbs up, Chad? We fully understand how powerful this system is. This is what our speaker is going to be talking about today. Okay? So before I let you guys go, I want you to understand this is what you're going to design for Chad in Revit. I want something called relay schedule. A circuit, a relay, a location. A minimum, right? When you do it in Revit, here's how we do it in Revit. In Revit, Kerry, my friend, you're going to pick this fixture exactly like pick a receptacle and circuit it first, right? Remember how we picked a receptacle? Circuit, circuit, circuit. Done. Done, done, done. Then you're going to pick the fixture again and go switch it. There's two buttons, one power, one switch. So you're going to pick the circuit here, first circuit here. Then you're going to pick the same fixture and switch it. So two sets of fixtures, guys, could be powered from the same circuit, switched from different switches. Did you see that? Powered from the same circuit, switched from different switches. So that's basically what you're going to be looking at. Any comments, any questions? Any comments, guys? Any questions about that?
No.
Rob is outside? Uh-oh. Oh, yeah. Hi, guys. Hey, come on in. I'm sorry. I didn't know that you're outside. Good to see you all. Come on in. Yeah. Hi. Chris is there. Come on in. We're almost done here.
All right.
Yeah. So you might be able to correct me here, too. All right. Any question, guys, about the lighting? Lighting control panel. The last thing I wanted to show, and I'm afraid to show it in the front of the expert, is I didn't show you can have a two-pole, a relay that drives two poles. So you can bring, that's the only thing I want to show. Here's my 24 volt here, and I can have two poles, meaning I can bring two circuits. Here's circuit 1, 20 amp, phase A, circuit 2, phase B, and I can bring this circuit to this, and this circuit to this guy, and come out of here, see two pole, and come out of here, and go to my lighting fixtures, right in here, and grab my fixture. Here's 18 fixtures here. Here's another 18 fixtures here, and I grab my light, bring it down here, bring this down here, and of course don't forget the neutral. So here's my neutral in this area, and come here, and from here shared neutral. So this is a two-pole relay, two phases, and you can control this one from a low voltage switch, like we said. Here's my 24 volt transformer, and grab it from here, out of here. This will come down here, and this from here for the most part come. So here's my switch. Oops. My switch is goofy. Okay, so that's what I wanted to show at the end. There you go. So I have my low voltage switches, and this is, remember, this is 24 volt. This is coming from 120 volt feeder. This is, you have 2-pole or sometimes 3-pole. They use the 3-pole contactors on parking lots. When you have a parking lot, you can have an occupancy sensor or a timer drive this relay to control the lights in the parking lot. Most of what we're going to do in this project in Revit is going to be single-pole relays. I don't see any need for 2-pole relays unless you want to have, in an area, you have like 18 and 18 fixtures in one area, you want to control them together. You can't control, depending on the watts, we said we want to cap to 18. You can't control these from one circuit, right? So one example is to have a 2-pole relay driven by the same pilot device, a switch, or an occupancy sensor. Any comments, guys, about single-pole, 2-pole, or even 3-pole relays? We have a speaker about lighting today, and he's going to talk about lighting control panel, so I'm warming him up a little bit here. Okay, so that's what our speaker doesn't go into the details of the wiring, and knowing myself, you can't understand what he's going to tell you today unless you understand these concepts that we talked about. Any comments, any questions? Okay, our speakers are almost here. So I'm gonna, let me save the PDF file here. And we're off.